All right, we're back. We're on page 8 of notes 10, and let's see what we're doing. So the graph of f prime, the derivative of continuous function f. So it's important that we're told it's continuous, actually, because if you look at the graph of f prime, there's this discontinuity here. If you weren't told that f of x was continuous, there's no way to know if f of 9 exists. But since we're told f is continuous, now we know that definitively f of 9 exists, the limit at x equals 9 exists, and the limit equals the value of the function. So we know those things. It's also given that f of 5 is 3. I don't know. All right. So this is a graph of f prime, and that's important, and by far the most common thing that you'll be given. Write the equation of the line tangent to f of x at x equals 5. Use the tangent to approximate f of 5.2. Is it an over or underestimate? Justify. So let's see. So we know this is true. So f of 5 equals 3 is given. F prime of 5, so this is a graph of f prime. Let's trace it. I don't know why. That's a graph of f prime, so f prime of 5 is 1, based on that. F prime of 5 is 1. So tangent line, so first tangent line. Tangent at x equals 5. Going to be y minus 3 is the slope is 1, x minus 5. I tend to leave them in point slope form because it doesn't really hurt. We want to approximate f of 5.2. So f of 5.2 is, auto shape. Look at you, a triangle. F of 5.2 is approximately, so I'm going to move the 3 over for the tangent line. Say it's 3 plus 1 times 5.2 minus 5, which is 3.2. Okay. Is this an over or underestimate and justify? So when we're talking about over and underestimates, I like to talk about concavity. And to talk about concavity, if I have f prime, I like to talk about if f prime is increasing or decreasing. So I'm going to look on the interval from 5 to 5.2, f prime is decreasing, which means f double prime is negative. Both of those mean f of x is concave down. And if f of x is concave down, then the tangent line is above, so we get an overestimate. So let's try to kind of formalize that. So I'm going to say on 5 to 5.2, f prime of x is decreasing. So that's enough. I could just say f prime is decreasing, therefore f of x is concave down. You might want to go the extra step. So I'm going to say which implies f double prime of x is less than 0, which implies that f of x is concave down. So if you're not sure when you have concave down, just draw something concave down and put a tangent line. And you can see, since f of x is concave down, the tangent line is above the curve, and you get an overestimate. So I'm just going to say f of x is concave down. I guess I'll say, therefore, the tangent line is above the curve. So this is an overestimate. So let's say 3.2 is an overestimate. Okay, so definitely an overestimate. Find and classify the critical points between -3 and 11. Almost always going to be an open interval. I think it will always be an open interval. So like that takes care of the fact, like what if f of -3 was 0? Like how would you classify that? Is it a critical point? Like it's definitely a critical point if f of -3 is f prime rather of -3 is 0. But like how do you classify it? You don't need to worry about that. Open intervals. What we do need to worry about is finding the critical points. So the critical points are where f prime is 0 or undefined. So 0, f prime is definitely 0 here. That's definitely -1.5. 0 here. And then undefined here. So we have 3. Oh, I jumped right over this one. Right here. And here. So many. Okay, so I see 1, 2, 3, 4, 5 critical points. 4 of them are critical points because f prime is 0. 1 of them is a critical point because f prime doesn't exist at x equals 9. So we have 5 critical points. I don't know what I'm going to do. 5 critical points. I guess I'll list them first. So critical points at f of x has critical points at x equals negative 1.5, 6, 8, 9, 10. Okay. I tend to write x equals, which is annoying. I acknowledge. You could do like a set. I just don't like it when people write x equals and then they do a list. Like that doesn't really make sense. X equals what? Like x is an element of this set, I guess, or whatever. So we have this. I'm going to group them by the ones, the critical points that lead to absolute, not absolute, relative maximums, and then the ones that lead to relative minimums, because I can justify them in a group, right? So anywhere f prime goes negative to positive, so negative to positive, negative to positive, and then that's actually it. Okay, so at x equals 9, there's a critical point because f prime doesn't exist, but f prime doesn't change sign, right? F prime goes positive to positive, so there's not actually a maximum or a minimum there. There's just a critical point. So we identified it as a critical point. We're just not going to really address it. So the relative minimums are occurring at negative 1.5 and at 8. So let's answer that first. So f of x has relative minimum at x equals negative 1.5 and x equals 8 because f prime changes negative to positive there. Okay, and then we want to do the maximum. So the maximums are where f prime changes from positive to negative. So positive to negative here, and then here. And again, 9, it's a critical point, but like nothing happens. And you get those sometimes. So 6 and 10 are our relative maximums. So f of x has relative maximums at x equals, what did we say? 6 and 10? X equals 10 because f prime changes. It's a lot of writing. Positive to negative. There. Boom. Okay, and then at 9, nothing's happening. So I'm going to like kind of ignore it, which feels rude, but it's basically what you do. I mean, we didn't ignore it. We listed it as a critical point, but it's not going to get classified as a maximum or minimum. So nothing we can do. Determine the x coordinates of the points of inflection and justify your response. All right, let's look. So points of inflection are going to be the relative extrema of the first derivative, because if the first derivative has a relative extrema, if the first derivative goes from increasing to decreasing or decreasing to increasing, it means the second derivative must go from positive to negative or negative to positive. So like that's why we're searching for those. There is, however, another point of inflection that's not at a relative maximum or relative minimum of f prime. It's just at a place where f prime changes from increasing to decreasing. So I'm going to say, I'm going to list all the ones that occur at relative extrema. So what color should I? I'm going to highlight or put, I'll put a point in red. So this is an interesting point right here, but it's not a point of inflection. It's not a relative extrema. It's a place, this is where f prime is not differentiable, right? This is a graph of f prime. F prime is not differentiable here. There's a sharp change, but it's not a point of inflection because f prime goes from increasing to increasing. It just goes from increasing one way to increasing a totally very different way, not smoothly at all. So not differentiable, but like not a relative max or min, not a point of inflection. So point of inflection for f of x will occur here because f prime has a maximum, will occur here because f prime has a minimum, will occur here because f prime has a maximum, will occur here because f prime has a minimum, and then will occur here because f prime changes from increasing to decreasing. So what I'm going to do is I'm going to say these 4, 1, 2, 3, 4. I'm going to say those 4 are points of inflection because f prime has a relative extrema. Then I'm going to say at x equals 9 because f prime changes from increasing to decreasing. So that's my game plan. So 1, 3, 4, 7. 1, 3, 4, 7. Let me just write that. 1, 3, 4, 7. Okay. So f of x has POI at x equals 1, x equals 3, x equals 4, and x equals 7, because f prime of x has relative extrema at those values, I guess. At those x values is probably a better way to write that, but whatever. And then at x equals 9, this, by the way, I could have used this explanation for all of them, but I just wanted to illustrate different explanations. At x equals 9, because, so instead of, well, let me do this. Because f prime of x changes increasing to decreasing. Okay, so notice I'm not saying anything about the second derivative. If you, I just think it's better to not do that. In this explanation, maybe, right? F prime changes from increasing to decreasing, which means that f double prime changes from positive to negative. F double prime is a sign change, point of inflection. It's more writing and it means the same thing. You're kind of just like duplicating what you've already written, but that's up to you. Like you have to decide what kind of answers you'd like to give. I will say that in this particular problem, we were given the graph of f prime. So base your answer, including your justification, on f prime. So like avoid f double prime, because then you have to like draw a connection between them. We don't really want to have to do that. So I think it's better if you're given f prime to just like work with f prime. But again, you know, as you do more of them, you might develop a different preference. I don't know. All right, I'm going to say that that's this page done. So I'm going to cut this video here, and I will come back in the next one and I think finish the notes. So I will see you there.